In this video, we'll take a look at unions, intersections, differences, complements of sets, and we'll also look at subsets. This is easiest to demonstrate by using a Venn diagram. In this case, we have sets A and B. The union of sets A and B is the set that contains all of the elements that belong to either set or both sets. The union is notated with this symbol. The symbol actually looks like a U, which makes it easy to remember. Note that when we describe the union of A and B, we are actually including any arbitrary value that is found in either set or both sets. The intersection of A and B includes only values that are contained by both sets. An intersection is notated using this symbol. If an element is only in A but not in B, then that element is not in the intersection, but it is in the union. You may have noticed that unions and intersections are functionally similar to the OR and operations used in logic. The union of A and B can be described as the set of values that are contained in set A or B, and the intersection of A and B can be described as the set of values that are contained by both A and B. Now, what about values that are included in A but are not included in B? We can also describe this as the difference between A and B. The difference of sets A and B is a set of elements that are in set A but not in set B. We notate this difference using a minus sign. The difference is sometimes referred to as the relative complement. Let's look at some examples. Here is the union of sets A and B. We include all of the elements for both sets. Notice that even though both A and B contain 3, 5, and 7, we only list them once. For the intersection of A and B, we only list elements that are contained by both sets. To determine the difference between A and B, we find elements that are in set A but are not in set B. Now let's take a look at the complement of a set. The complement includes all elements that are not contained within that set. There are different common notations used to indicate the complement of a set. For these videos, we will notate the complement of a set by using a line over its name. Using set notation, we can define not A by showing that X is an element of the universal set, such that X is not an element of A. There are other terms that can be used to describe the complement of a set. These include not A or A prime. Now, what if we want to define only a portion of a set, such as a subset? Let's define two sets, A and B. In this case, we can see that set B is a subset of set A, and we can notate that like this. Since B is a subset of A, but is not completely equal to A, we say that B is a proper subset of A. Another way to indicate a subset is by adding a line underneath the notation for a subset. If we use this notation, we are still saying that B is a subset of A, but B can also be equal to A. This is comparable to a less than or equal symbol. This means that any set is technically a subset of itself. So, if our subset symbol has a line underneath, we're saying that B is a subset or equal to A. If it doesn't have a line underneath, we are saying that B is a proper subset of A, meaning that B contains some of the elements of A, but not all. An important subset is the empty set, which uses this symbol. The empty set is sometimes referred to as the null set. The empty set is also represented by using an empty pair of braces. As you can probably guess, the empty set refers to a set or a subset that contains no elements. Remember, all sets contain the empty set.